The Sun, a magnificent celestial body that has fascinated humanity for millennia. A giant ball of fire in the sky, radiating light and heat across the solar system. It's the reason we're alive, providing the essential energy that sustains life on Earth. Without the Sun, our planet would be a cold and dark place. No life could exist and the Earth would be a barren wasteland. The Sun is our very own star, a beacon of light in the vastness of space. It's a giant nuclear reactor in space, providing us with the energy we need to survive. Through nuclear fusion, it converts hydrogen into helium, releasing immense amounts of energy. We see the Sun every day, rising in the morning and setting in the evening. It rises in the east and sets in the west, marking the passage of time and the rhythm of our days. But how much do we really know about this incredible object? Despite its daily presence, the Sun holds many mysteries. What is the Sun made of? How does it sustain its fiery brilliance? How does it produce so much energy? The process of nuclear fusion at its core is a marvel of nature. And what is its future? The Sun, like all stars, has a life cycle. One day it will expand into a red giant and eventually shed its outer layers. The Sun is a fascinating object with a surface that is constantly changing, erupting with solar flares and prominences. It's been studied by scientists for centuries, from ancient astronomers to modern-day astrophysicists, and there's still much more to learn. Each new discovery brings us closer to understanding our star, but we do know a lot about it already. We know about its composition, its energy production, and its impact on our planet. And what we know is truly amazing. The Sun is not just a source of light and heat, it's a dynamic and complex star. In this essay, we'll explore the Sun in more detail. We'll delve into its structure, its life cycle, and its influence on the solar system. We'll learn about its structure, composition, and how it produces energy. We'll uncover the secrets of its core and the processes that power it. We'll also look at how the Sun affects Earth and what its future holds. Solar activity can have profound effects on our planet, from beautiful auroras to disruptive solar storms. So, let's begin our journey to the center of our solar system and unlock the secrets of our very own star, the Sun. Join us as we explore the wonders of this magnificent celestial body. The Sun is huge. It's a massive glowing sphere of hot plasma at the center of our solar system. It's about 109 times the diameter of Earth. To put that into perspective, if Earth were the size of a nickel, the Sun would be about as big as a yoga ball. That means you could fit over 1 million Earths inside the Sun. Imagine 1 million tiny Earths packed into a single colossal sphere, and it's heavy too. The Sun's mass is about 333,000 times the mass of Earth. This immense mass generates a powerful gravitational pull, keeping the entire solar system in orbit around it. But the Sun isn't solid like Earth. It's a gigantic ball of gas constantly in motion. It's made up of gas, mostly hydrogen and helium. These two elements make up about 98% of the Sun's mass. These are the simplest and most abundant elements in the universe. Hydrogen, the lightest element, is the primary fuel for the Sun's nuclear fusion process. There are other elements present in the Sun too. Elements like oxygen, carbon, neon and iron are also found, but in much smaller quantities. These trace elements play a crucial role in the Sun's complex chemistry and energy production. The Sun is like a giant onion. It has layers. Each layer has its own unique properties and functions. The innermost layer is the core. This is where the Sun's energy is produced through nuclear fusion. This is where the Sun's energy is produced. In the core, hydrogen atoms fuse together to form helium, releasing a tremendous amount of energy in the process. The next layer is the radiative zone. Here, energy from the core travels outward in the form of radiation. Energy from the core travels through this zone in the form of radiation. This process can take thousands of years, as photons are absorbed and re-emitted countless times. The convective zone is the outermost layer of the Sun's interior. In this zone, energy is transported to the surface by convection currents. In this zone, energy is transported to the surface by convection. Hot plasma rises, cools as it nears the surface, and then sinks back down to be reheated and rise again. The Sun's surface is called the photosphere. This is the layer we see from Earth, and it's where most of the Sun's visible light is emitted. This is the layer we see from Earth. The photosphere is a thin layer, only about 500 kilometers thick, but it's incredibly important. The photosphere is a very active place. It's covered in sunspots, flares and prominences, all of which are fascinating to observe. It's covered in sunspots, flares and prominences. These features are caused by the sun's magnetic field and can have significant effects on space weather. The sun's core is a powerful place. It's here that the sun's energy is generated. The temperature at the core is about 15 million degrees Celsius, and the pressure is immense. It's about 200 billion times the pressure at sea level on Earth. Under these extreme conditions, hydrogen atoms fuse together to form helium. This process is called nuclear fusion. Nuclear fusion releases a tremendous amount of energy. This energy is what powers the sun. The energy produced in the core takes a long time to reach the surface. It can take hundreds of thousands of years, but once it reaches the surface, it's radiated out into space in the form of light and heat. The sun has been producing energy this way for billions of years, and it will continue to do so for billions more. The sun is a very efficient energy producer. It converts about 600 million tons of hydrogen into helium every second. That's a lot of energy. Section 4. The sun's hazy halo. The sun's atmosphere is made up of several layers. The lowest layer is the photosphere. This is the layer we see from Earth. The photosphere is about 500 kilometers thick and has a temperature of about 5,500 degrees Celsius. Above the photosphere is the chromosphere. This layer is about 2,000 kilometers thick and has a temperature of about 10,000 degrees Celsius. The chromosphere is usually invisible to us, but during a total solar eclipse, we can see it as a reddish rim around the sun. The outermost layer of the sun's atmosphere is the corona. The corona is a very hot and tenuous layer. It extends millions of kilometers from the sun. The temperature of the corona can reach millions of degrees Celsius. The corona is a mysterious place. Scientists don't fully understand why it's so much hotter than the sun's surface, but they think it might be due to the sun's magnetic field. Section 5. The sun's dance of light and dark. The sun's surface is not a calm and peaceful place. It's a roiling, boiling cauldron of plasma, constantly in motion and full of energy. The surface, known as the photosphere, is where we can observe these dynamic changes most vividly. It's a constantly changing and dynamic environment. The sun's surface is a tapestry of swirling gases and intense magnetic fields, creating a mesmerizing dance of light and dark. One of the most noticeable features on the sun's surface is sunspots. These dark patches are fascinating to observe and study. Sunspots are dark, cooler areas on the photosphere. They appear darker because they are cooler than the surrounding areas, though still incredibly hot by Earth standards. They're caused by the sun's magnetic field. These magnetic fields inhibit the flow of hot plasma, causing the temperature to drop in those regions. Sunspots can last for a few days to a few months. Their lifespan depends on the stability of the magnetic fields that create them. They come in different sizes. Some sunspots are small, barely noticeable without a telescope. Others can be larger than Earth. These massive sunspots can be seen even with basic solar viewing equipment. The number of sunspots on the sun's surface varies over time. This variation is not random, but follows a predictable pattern. This is known as the solar cycle. The solar cycle is a roughly 11-year cycle that affects the number and size of sunspots. The solar cycle lasts for about 11 years. It starts with a solar minimum, a period with few sunspots. At the beginning of the cycle, there are very few sunspots. This is the solar minimum, a time of relatively low solar activity. But as the cycle progresses, the number of sunspots increases. This marks the approach towards the solar maximum. At the peak of the solar cycle, there are many sunspots on the sun's surface. This period is known as the solar maximum. The sun is also more active during this time. Increased solar activity means more solar flares and coronal mass ejections. There are more solar flares and coronal mass ejections. These are powerful bursts of energy and matter from the sun. These are powerful bursts of energy that can disrupt communications and power grids on Earth. They can also create beautiful auroras near the poles. Section 6. The sun's gift and fury. The sun is essential for life on Earth. It provides us with light and heat. Plants use sunlight to make food through photosynthesis. This process releases oxygen into the atmosphere, which is essential for animals to breathe. The sun's energy drives our weather patterns. It heats the Earth's surface unevenly. This creates differences in air pressure, which causes wind. The sun also powers the water cycle, evaporating water from the oceans and lakes. This water vapor eventually falls back to Earth as rain and snow. But the sun can also be dangerous. Too much exposure to sunlight can cause sunburn, skin cancer, and eye damage. The sun also emits harmful radiation, which can be dangerous to astronauts in space. The sun's activity can also disrupt our technology. Solar flares and coronal mass ejections can damage satellites, interfere with radio communications, and even cause power outages. This is why scientists constantly monitor the sun, to better understand its behavior and to predict when these events might occur. Section 7. Unlocking the sun's secrets. The sun is a fascinating object, and scientists are constantly learning more about it. Spacecraft like SOHO, the Solar and Heliospheric Observatory, and SDO, the Solar Dynamics Observatory, are providing us with incredible images and data of the sun. These missions are helping us to better understand the sun's structure, composition, and behavior. Scientists are also studying the sun to learn more about other stars in the universe. By understanding how the sun works, we can better understand how stars form, evolve, and eventually die. The sun is our closest star, and it's a natural laboratory for studying stellar astrophysics. The sun is a powerful and enigmatic object. It's the source of life on Earth. But it can also be dangerous. By studying the sun, we can learn more about our place in the universe, and we can better protect ourselves from the sun's harmful effects.